Okay, this will be the last video of our 3.2 lesson. In this video, I will go over example 5, 6, and 7 on pages 4 and 5. If you watched the first two lessons, then you are actually ready for the 3.2 daily problem. The submission link is on Canvas, so you can try part A, B, C, D and submit it for me. Please before Sunday so that I can give you feedback in case anything is wrong, okay? Now, you don't really need this part for your daily problem, but I thought I created these examples based on your My Math Lab homework 3.2. There are some graph reading or graph choosing problems that you will have to do on your 3.2 homework on My Math Lab. And these are just something that I created thinking that they may help you, okay? I think it's easier to use graphs given than actually sketching it ourselves. So what I'm going to do is I'm going to do example 6 and 7 first, and then I'll come back and sketch graphs with you on example 5, okay? So start with page 5, example 6, okay? Let's do this one together. The graph of f of x is shown. Assume f is twice differentiable. So here's our graph of x. And what they are saying is twice differentiable, we can find the first derivative and we can find the second derivative. They are saying at x equals -1, that's the point they're interested in. X equals -1. I have a point right here. The graph of f, notice how this graph is going down from left to right. We know this is decreasing. F is decreasing. And how I saw on your homework, I think they made it like into a drop-down menu. It's either decreasing or increasing, so you choose one. So this graph is going down from left to right. So f is decreasing at that point. And it is concave blink. So up or down. Okay. And you know how I do it. I always try to think about that frowny face or happy face, right? So if you take a look, this will be a graph with a little happy face. So I know this is concave up, but let me try to find a better way of explaining this, okay? Concave up graphs, when you draw a tangent line at that very point, the curve of the graph, the graph will be above the tangent line. You see how our blue line is above that straight tangent line? So that's one way of telling that this is a concave up graph. Or you can look at the slopes to the left and right of it. So you may do something like this. Let me try to sketch some slopes here or tangent lines here. So notice this tangent line, another tangent line, another tangent line. So you can keep on drawing tangent lines. And this is a rapidly going down graph, right? This is a negative slope. But notice how it kind of leveled out, I will say. And then at that point, keep on going. I mean, if you follow this, notice at some point it's gonna get a zero slope, a tangent line that has a slope of 0, and then it's gonna start increasing. So and that's how we tell the concave up or down. Now, wish the picture was a little more extreme. Like if you have a picture like that, then it'll been a little bit easier for us to see that the slope of the tangent line is increasing, like from negative to 0, that's going up, and then it's gonna go up to positive. But this graph looked almost flat, so it wasn't really easy for us to tell, but this is a graph that is concave up. Okay? All right. And I guess the easiest way of telling that is just that if you sketch a tangent line, the graph will be above, this graph is above the tangent line. And that implies this is concave up. Okay? All right. Which one of these is the smallest? Interesting. F of -1. We actually do know the value. F of -1 is +3, right? We know f of -3 is +3. Well, I'm going to say this is a positive value. Okay, now let's look at the second one. F prime of -1. Now, we may not know the exact number, but here's what we know. We know this function is decreasing. That means the slope of the tangent line. I mean, take a look at this line that I drew right here. This line is going down from left to right, right? So what must be the slope of that line? Well, we don't know the exact number, but we know this is going to be negative, right? So the slope is going to be negative. Last one, f double prime of -1. F double prime of -1. Now, what can we use? I mean, we're not going to know the exact number, but here's what you know already. Let me highlight this clue for you. This graph is concave up. And in order for a graph to be concave up, your second derivative must be greater than 0. This must be positive. So, which one of these is the smallest? Now, although we don't really know the exact value at these of what they are asking, what we know is that these two are positive, and this is the negative. And what we know is negative is always smaller than positive. So we can say f prime of -1 is the smallest. And that's what you can do. That's what you can do, just kind of figuring out which one is positive, which one is negative. Like in this problem, I wouldn't know which one is the greatest. But maybe you will get a problem where they give you two of the values come out to be negative and only one of them is positive. And then in that case, you can tell the only positive value is going to be the greatest. But there are some interesting problems that my math lab will randomly generate for you. So if you're not sure, click on email my instructor, or like, what does it say? Like, help me, you know, if you email me about a question on your homework, I can go over that real quick with you, and then I can send you the link of me going over that problem. So do that for me if you get something that's not too something that's a little complicated, or you think, well, but they're going to be very similar. But anyways, let me keep going, okay? Example 7. Now, given the graph below, find the intervals where f is concave down, concave up, and an inflection point, a point of inflection. So we got a graph right here, and we know two things. If I get a picture like that, that will be concave down. And what does concave up look like? This will be concave up. Okay, so let's find all the section that looks like concave down. I can see this right here. That section right there is concave down. Like, I can see a frowny face right there, right? Oh, upset face. Now, which section is concave up? From that point all the way to the right, I can see this is a little happy little face right there. So this section will be concave up. Or you can try to draw some tangent lines. So if I try to draw some tangent lines here, tangent line here, tangent line here, tangent line there, tangent line there. All these tangent lines are above, or I should say the graph is below the tangent line, so that will be concave down. And if I try to draw some tangent lines here, here, and there, notice how the slope is going up, increasing, and then the entire graph is above. Well, at least from that section on, the graph is above all these tangent lines. So we found where it is concave down and where it is concave up. And we also see at that point right there, oh, I deleted everything. This point right there is where that concavity changes. So we will say this point right here for -1 is the point of inflection. Okay, so let's write our answers. This is concave down on -infinity to 4. Concave up on 4 to +infinity, and the point of inflection is at 4, -1. Okay? What's great about my math lab homework is that you can miscouple, and then they will keep on giving you similar problems, right? I can only go over like 1 or 2 examples with you, but I need you to really practice. This is one example, but I need you to keep on trying your homework problems until you completely really get this, because this can be a little tricky if you think about it. All right, so that's enough for picture reading. I'm going to go back and actually sketch some pictures, okay? It's a little tricky idea here. All right, f is increasing and concave up on negative infinity to positive 3. And I want a graph that is increasing, but this time concave down from 3 to positive infinity. Now, quick reminder what concave up and down look like. This is concave up, and this is concave down. All right, let me see. I'll write down this is concave up, and this is concave down, right? Now, first part, they want increasing concave up. Increasing concave up. Look, this is the concave up graph, but to be increasing, I need to look at this section. So the graph to the left of positive 3 should look like that, what I'm highlighting or tracing in red. Okay, so this will be the graph for negative infinity to 3. And the second part, what they want is increasing but concave down to the right side of 3. So increasing but concave down will be this section. This is the section that's going up from left to right. So what I'm going to do is I'm going to put this red and blue piece together in a single graph, and that's how we will sketch the graph. So here's my number line, x and y axis at positive 3, 1, 2, 3. This is where that point of inflection will happen because the concavity changes from left to right. So here we go. Let me go ahead and do the negative infinity to 3 first. Negative infinity to 3, I need to copy something that looks like that. So something like this, right there. And then from positive 3 to infinity, I need a picture that looks like that. So I'll just go from here to there. And that's how you can sketch the graph. And you know, this is just a sketch. This is just a sketch. So you can have couple other graphs, but this will be the shape of your graph. And what you will do is on your My Math Lab homework, you're just going to have to choose from one of the following graph they will give you, like in a multiple choice format. But that's good. Let's look at another one. G is concave down at. Now look, if they were giving you an interval, they would say something like concave down on, O-N, but they're saying concave down at 1/6. So this is a point. This is a point that this is we'll mark it together. Concave down at that point 1/6, and this is concave up at 5, -2, and we have a point of inflection at 3, 2. So we got 3 points to plot. Let me do that first, and then we'll try to sketch a graph, okay? So this one, you see all these submissions that I'm getting. I'm happy. I'm excited to grade all these work. 1, 2, 3, 4, 5, 6. Oh dear. Here is my first point they gave me. This is where I'm gonna sketch concave down. This is where I'm gonna sketch concave down. Real quick, what does concave down look like? Concave down look like this, a frowny face. Okay. So what I know is I'm gonna have a graph that looks like this over here. Okay, just being extreme, like a concave down graph right here. All right, what's the next one? Concave up at 5 to the right. 1, 2, 3, 4, 5 down 2. So this is where I'm gonna have concave up, they say. And what does concave up look like? It looks like that, right? All right, what else did they give you? We have a point of inflection at 3, 2. 3, 2. This is where the change of concavity will happen. This is our POI. I'm just going to connect these graphs now. So concave down I love using highlighter. From here to there, concave down from here to there. And then from this point of point of inflection, I'm going to have a graph that turns around and do concave up. So this will be a graph of G. This will be a graph of G meeting these 3 conditions that they listed for me. Alrighty. Let's sketch 2 more graphs. Ooh, this is going to be an interesting case. So they said F is positive. So what does that mean in a graph, guys? F is positive. That means all the Y values are positive. In a graph, if all the y values are positive and you try to sketch it, the graph will be completely above the x-axis. Because if you go below the x-axis, then f will be considered negative. So for this piece of graph, we're going to have the entire graph somewhere above here, okay? Somewhere above here. And it's not going to look like that, but we know we're not going to go in the bottom of that x-axis, okay? So that's what it means. F of x is positive implies that the graph is above the x-axis. So I'm only graphing this graph on the first quadrant or the third quadrant. I'm not going, oh, that's not the third quadrant. Look at me messing up, guys. I'm sorry. Or the second quadrant. So I'm only going to graph my picture above here. So that's the first condition. What else do we know? We also were told that f prime is negative. Oh, now let's talk about that. What that means is slope of this tangent line is going to be negative. And having a negative slope means this graph is going down from left to right. This is a decreasing function. F must be a decreasing function to have a negative slope for a tangent line. So I kind of get an idea. I'm going to sketch a line that's going down from left to right. That's completely above the x-axis. And that's what I sketched so far. But I still need to take a look at the third condition they mentioned, right? So let's look at the very last one. And this one is a little bit tricky, guys. This one's a little bit tricky. They said f double prime is 0. F double prime is 0. Let me try to connect this to some fake f double prime. So imagine a graph that has a second derivative that's equal to 0. Remember, whenever we take derivative, don't we go down in the degree, right? So if f double prime is 0, f first prime or f prime or the first derivative must have, let's say, I'm just making up, it's just like, not x. Must have just like a constant. Like I'm just going to say like -2. Just a constant. I'll think about taking the derivative of -2. And if you're wondering where did you get -2 from, I just made it up. But don't you agree that the derivative of a constant, a number, is going to be 0? Right? So what may be f of x? What may be f of x? We're kind of going up. Oh, we're kind of going up. How about if I think about something like -2x? Wouldn't the derivative of -2x be -2? So I'm just kind of thinking, and the reason I put the constant to be, or the coefficient to be negative, is because I knew that the function is decreasing. But I wanted to show you to have a second derivative of 0. The original function should just be a linear case. So that from linear to the first derivative, you lose that x. And then from first derivative to the second derivative, and then the constant will just give you 0 for its derivative. So that's how I kind of see it. You can also think about the second derivative being 0 means a graph not having a curve. Because if you sketch a straight line, I think I'm ready to sketch a straight line that's going down from left to right. This will be a graph of x, I would say. This will be a graph of x. Because it meets all the conditions. Well, the piece that I just drew is completely above the x-axis. If I continue, though, this is going to go down eventually below the x-axis. But for right now, the little gray piece that I sketched is above the x-axis. So f is positive. And f prime is negative because this is going down from left to right. And if you talk about the concavity of this graph, if you try to draw a tangent line, let me do that right here with you, okay? If you try to draw the tangent line, slope of the tangent line will just be, how would I, it's not changing. The slope of the tangent line is not changing at all. And The second derivative is the rate of change of the slope of the tangent lines. So if there is no change in the slope of the tangent line, then the second derivative is 0. Now this sounds way too complicated. And I'm saying it. Oh, I don't know. Hopefully, guys, if this is making sense, but I'm sure if you try all these my math homework problems, keep on trying until you get these. But definitely, maybe this may be a good lesson where you come in for a virtual office hour, and so that you and I can have a meeting to discuss this a little more. But if I'm confusing you please email me and let me know, okay? But let me go ahead and finish the very last one and let you go and try your homework problems. All right, the very last one, they said f is positive. F is positive. Oh, I know this. F is positive means my entire graph will be above the x-axis with all positive y values. So I know I'm going to have a graph that's completely above the x-axis. F is positive. What else do we know? They also said, oh, look, f prime is 0. F prime is 0. That means this graph is not increasing or decreasing. I mean, how else can I graph this picture other than a horizontal line? So I graphed a straight line, a horizontal line. Now let me see if the last piece makes sense. They also said f double prime is 0. F double prime is 0. Well, that means the rate of change of slope of tangent line is 0. So basically what they're saying is the the tangent line for each of these points on this line is going to remain the same. So look, a tangent line at this point, tangent line at that point, tangent line at that point, tangent line at that point is not changing. So, I deleted my line. Or if you want to do a little bit of algebra or making up some random functions, you may write down that f double prime is 0. That means f prime must be a constant, right? And a constant, I may just make it up to be like 3. But then I'm going to have a problem because if I have that, the antiderivative of 3 will give me 3x. So that probably doesn't work. How about I make it to be like just 0 there? And then I can have like, say, 3 right there. The derivative of 3 is going to be 0. And the derivative of 0 is going to be just 0. So, this looks like a graph of y equals 3. So that may be like one equation. Y equals 3 maybe it's an equation that satisfies these 3 conditions. But to satisfy all these 3 conditions, it must be, the original graph of f of x must be a horizontal line above the x-axis. How tricky to think about. But at least in the good news, when you're doing these on your homework problem, you will be given like 4 or 5 to choose from. And you may be able to use that process of elimination to cross out some of the wrong ones. Like they said f is positive, and if any part of the graph goes below the x-axis, that's not going to be the answer. Things like that. But I wanted to include some examples on this part of that will help you on the homework. I don't know if this was exactly helping, but this is a good point. Way for us to start up a conversation if you are having any issues, because I haven't had any students in our class 261 coming in for a virtual office hour yet. Looks like you guys had a great first week back on week 9, but if you're having any issues doing your homework or doing your classwork problem, please email me so that we can set up a Zoom video conference to have a one-on-one meeting, okay? All right, so that's enough. I want you to submit the 3.2 problems for me on Canvas and do work on your 3.2 homework where you will see all these fun graph reading or sketching graph problems, okay?